Welcome to another video, guys. Today we're showcasing our supply continuity circuit using basic electronic components. This circuit ensures a connected load remains powered briefly, even after the main supply is turned off. Using basic components like capacitors, resistors, a potentiometer, and a diode, this simple and cost-effective design is perfect for applications like emergency lighting or low-power backup systems. Let's take a look at the circuit diagram and the components used in our project. This circuit ensures the load remains powered briefly after the main supply is turned off. It includes capacitors to store charge, a diode to block reverse current, resistors to control current, a potentiometer to adjust discharge time, and an SPST switch for supply control. The LED represents the load. The quantity and specifications of the components are as follows. 1. 2 capacitors of 470 microfarads. 2. 1 resistor of 10 kilo ohms. 3. 1 resistor of 100 ohms. 4. 1 potentiometer of 100 kilo ohms. 5. 1 PN junction diode, 1N4007. 6. 1 LED of 5 millimeters. 7. 1 switch. Now let's take a look at how the circuit looks after being mounted onto the PCB, followed by a practical demonstration of its functionality. This is how the circuit looks after soldering onto the PCB. The video demonstrates its working. The LED stays on for approximately 10 to 12 minutes after disconnecting the battery from the circuit. That's why we call it the supply continuity circuit. This project showcases the practical use of capacitors for energy storage and gradual discharge to ensure uninterrupted power supply. Using basic components like resistors, diodes, and capacitors, here's how the circuit works. Initially, when the supply is connected, both capacitors are discharged, so they start charging. That's why the LED takes some time to turn on. Now the 100 ohm resistor comes into play. It slows down the charging of the second capacitor and also increases the discharging time of the first capacitor. And finally, the PN junction diode makes sure there's no reverse current, keeping the circuit safe and working perfectly. That's all for this video.